So clearly I'm not at school today. So I made a quick video for the lesson today over cylinders. It's pretty straightforward. It's very, very, very similar to our prisms and how we figured out surface area, volume, and all of that of our prisms. So today should be pretty easy to understand. When you are done, you guys have a worksheet over cylinders. And then tomorrow, make sure you come with any questions that you still have over 12.1. You know, the basics of our polyhedron, anything with the solids, anything with Euler's formula, and then any additional questions that you still have about prisms, and anything that comes up today during this video or the worksheet. Make sure you bring those tomorrow, because tomorrow is the only review day before the first mini test on Friday. Okay, so make sure you come with those questions. Okay, so let's do a quick little review of prisms. So here we have that hexagonal prism. We have the bases being the hexagons and the lateral faces being the parallelograms or the rectangles. So to figure out the volume, remember we took the area of the base times the height. We need to figure out how much area it covers in the base and then fill it up. But just one area of one base, not both. Lateral area, I just figure out the area of all of my lateral faces. So everything but the bases. And then surface area, I just add the area of both bases to the lateral area. And then I get the surface area. Okay, so hopefully that is review. We are good to go on that. If not, make sure you're jotting down the questions you still have for tomorrow. Okay? Okay, so a cylinder. Basically, it's really, really similar to a prism. It just has circular bases. So now I'm not going to say that I have any lateral faces. I just have a lateral area. Okay? If you can picture a soup can, take the label off that soup can. That is your lateral area of a cylinder. And then clearly your bases are the circles. So a few definitions, if you will, which hopefully are pretty obvious. We have the bases being circles. Okay, you see those. And then I already said this, the lateral surface or the lateral area is going to be, if you could peel off that label of a soup can or something like that, that's your lateral area. Because we have the circles for the bases, you have a radius. And then between the bases, if that height is perpendicular like this is, that is the height of your cylinder. But remember, you could have something that looks like this, where you have the right cylinder that we just showed where the height is perpendicular inside. But we could take an oblique cylinder and kind of push it over. This is no longer our height because it's too long. So remember, in an oblique cylinder, just like an oblique prism, you have to go outside. So I draw this vertical line down and connect it, and there's my right triangle to get that vertical height. Okay, and then again, remember that the height just has to be perpendicular to the bases. So we could turn both of these cylinders on their sides and have the height being horizontal. So just make sure you pay very, very close attention to that. I know some of those issues came up yesterday on the worksheet from Monday night. So just make sure you remember that it's not always the vertical height, okay? The vertical line. Alright, so hopefully this makes sense, all the definitions, all the parts to a cylinder. So we're going to jump right into lateral area. So again, the lateral area is that label on a soup can. Okay, if I pull that apart, yes, it's a rectangle. But when I put that back together and actually look at the cylinder, do I see where the length times the width is? Okay, and some of you are going to say, no, not right away. I don't understand what the length would be. So for a second, picture this net. Picture if you could pull apart that soup can and lay it flat. You have the two circles as the bases, then you have that rectangle. Think of where you're going to get the length and the width. One should be kind of obvious because one, it's labeled on this picture. The other might not be. So think for a second how you're going to figure out that area of the rectangle without having the length and width. Think for a second. hopefully some of us are thinking about the perimeter of the rectangle. So you're picturing that net, you're picturing how you would figure out length times width. And if you pull this guy apart, hopefully that perimeter is sinking in that it is the circumference. So the perimeter of the base times the height is how you're going to figure out the lateral area. So ultimately what it comes down to, do you know the circumference? So 2 times pi times r times the height. Okay, and if this doesn't make sense exactly to you right now, we will definitely have a example for you in class tomorrow. Okay, so just make sure you write this down right now. Lateral area is equal to 2 pi r h, perimeter or the circumference times the height. Okay. All right, moving on to the surface area. Remember, surface area is everything that you can physically touch. So you're going to touch the two bases, and then you're going to touch the lateral area. So the area of one base, hopefully we remember, it's a circle, so it's pi r squared. You have two of those, so you want to take 2 times the area of the base. Okay, so remember, capital B represents only one base. And then take that times the lateral area, which is 2 pi r times height. So here's your equation for surface area. Surface area is equal to 2 pi r h plus 2 pi r squared. Lateral area plus the two base areas. Okay, so make sure you get that down. Okay, moving on to volume. Remember, volume is how much an object can be filled up. How much an object can be filled up. So remember, some of us are asking, well, do I have to find the area of both bases? And remember, my answer is always no. Because think of a, like a water jug or something. You don't want to overflow that water jug. So that's why, clearly, you have a bottom and a top. You are going to figure out how much your base can hold, how much that bottom can hold, and then you just fill it up. Okay, so volume is just going to be the area of the base times the height. So here it is just going to be pi r squared times h. Okay, that's simple. And 9 times out of 10, you are actually going to leave your answers in terms of pi. So in this case, all that you would have to do is take the radius and square it, and then multiply that number by h, and you put pi next to that number. Okay, that's what it means to leave it in terms of pi, or what it means to leave it exact. Okay, make sure you get that done. All right, here is the example that we're going to do today. So after this, you'll get your worksheet, and hopefully you can get most of that done in class today. So let's look at this. Make sure you draw this out too, so you know where you get all these numbers from. Do your best to make a cylinder. I know 3D drawings are sometimes hard for us, but do your best. Okay, you're going to find the surface area and the volume of this cylinder. And again, you're going to leave your answers exact. So you're going to leave them in terms of pi. Okay, so reading this picture, you see that you have a height of 8, because that's the distance between the bases, and then you have a diameter of 10. Now, you've got to remember that you only need the radius. So you're going to cut this in half and get 5. So the area of one base is pi r squared. So all I'm going to do is take 5 and square it, and then multiply by pi. So if I'm leaving it in terms of pi, the area of one base is 25 pi feet squared. Okay? Hopefully that's pretty easy for you. And then the lateral area. So remember, that's the soup cans labeled, if I could pull that off. So I'm just going to take the perimeter times the height. That's the length times the width. So the length here is going to be 2 times 5 times pi, and then I'm going to take that times the height, which is 8. So 2 times 5 is 10, 10 times 8 is 80, and then I just leave it in terms of pi. So it's 80 pi feet squared. So let that sink in for a second. If you have a question on that, jot it down, and then we'll cover that tomorrow. But hopefully that makes some sense for you. And then surface area, everything I can physically touch. So I'm going to take the area of both bases. So this is the area of one, so I've got to double that. And then I'm just going to simply add the lateral area onto that. So I have 50 pi for the area of both bases, plus the lateral area of 80 pi, which gives me a total of 130 pi feet squared for the surface area. Okay, so hopefully that makes sense and you're getting this written down. And then the last thing we have to figure out is how much is going to be in this cylinder. Okay, so how much soup is in a soup can, or how much water is in a water bottle or anything like that, or how much pop is in a pop can. Figure out the area of the base. So the area of the base, I'm just going to take 5 squared times pi. So 25 pi, and then I've got to fill it up, times 8. So 25 times 8 gives me 200 pi feet cubed. And that's it. So it's very, very, very similar to our prisms in that you're still just finding the lateral face here, which is a rectangle, but you got to remember that you have to take the circumference times the height, because that becomes your length times width. The surface area is still the same. It's the lateral area plus the area of both bases. Volume is still how much the base can hold, and then you fill it up. The only thing that changes is now we have circles for bases, and honestly, cylinders are a little bit easier now, I hope, because we just have circles for bases. We don't have those hexagons and heptagons that we need to find the area for. It's just pi r squared. Okay, so hopefully that makes it a little bit easier for you. So your cylinder worksheet is what I want you to work on right now. Please work with your groups, but make sure you guys are on task the whole time. Try to get at least, 3/4 of this done. You guys should have plenty of time to do that. Um, Circle any that you have a question on, but make sure you try to get those done. Try to work through them if you run into any issues. Okay, we will talk about this tomorrow when we review 12.1 prisms and cylinders. Have a good rest of your day, guys. We'll see you tomorrow.